Hey guys, this is our Exponents Part 2 video. This is going to be all our rules for dividing. All the rules for dividing. Last time was the rules for all the multiplying. Now we're going to look at rules for all the quotients. So let's jump in. Okay. Dividing powers with the, again, same base. Got to have that same base in order for this to work. So when you're dividing powers that have the same base, you're going to keep the base, so in this case a, and subtract the exponent, top minus bottom. A, again, is a non-zero number. M and N are integers, although you can learn about how to simplify powers where M and N would be fractions. They're called rational exponents. Algebra 2. So look at a couple examples here. 2 to the 6th over 2 to the 2nd is 2 to the 6th minus 2, which is 2 to the 4th. Now this is a good example real quick for me to show you why this works. So 2 to the 6th power, let's see, I know 2 to the 5th power is 32, because that's 2 times 2 times 2, 6 times, right? So this is going to be 64 over 2 squared is 4. 64 divided by 4 is 16. 2 to the 4th is also 16. So I can show you right there that it absolutely does work. All right, so for the other one here, same idea, except this time the base is a variable. 4 minus 7 gives us -3, and then we rewrite with a positive exponent. So there's your quotient of powers rule. It kind of makes sense that for multiplying and for multiplying powers, you're adding the exponents together. Multiplication and addition kind of go together. And for dividing powers like this, you're subtracting the exponents. Division and subtraction kind of go together. You know, when you multiply and when you add, you get bigger answers. When you divide or subtract, you get smaller answers. So that's one way to think about it. Okay, let's try some. So several quotients of powers. Okay, y to the 9th over y to the 4th. We're going to keep the base, so the base is the y part. Keep the base, subtract the exponents. 4, not a 5. Let's try that again. 9 minus 4 is 5. So y to the 5th power is what we get. Now real quick, because again, it's not a bad one to write all the way out. Let's think about what this means writing it all the way out. 1, 2, 3, 4, 5, 6, 7, 8. I'm out of space, put one over here, 9. 9 y's multiplied out, 4 y's multiplied out. Every duplicate cancels out because top to bottom we can cancel out the common factors. What's left? 5 y's in a product, or y to the 5th. So d to the 6th over d to 9th, keep the d. 6 minus 9 is -3. D to the -3 is 1 over d to the +3. Next one. Okay, this time we got two different bases, so deal with the k first. K to the 6 minus 1, don't forget about that invisible 1. And then j to the 2 minus 5. 6 minus 1 is 5, so k to the 5th is in my answer. 2 minus 5 is -3. So we already learned in class that that part can't stay. It's got to go underneath to the bottom of the fraction, which may not have existed before in terms of where you could see it, but you know, anytime you have anything in math that isn't a fraction, you could write it with a denominator of 1 if you want to. Okay, let's do the next one. Keep the base, subtract your exponent. So -3 minus 5, and b to the 7 minus 2, so that's going to be a to the -8 times b to the 5th, which again, downstairs. So b to the 5th stays up top, a to the +8 in the denominator. All right, so that's quotients of powers. Let's look at what happens when you have a power of a quotient. Okay, raising a quotient to a power. To raise a quotient to a power, raise the numerator and denominator to the power and simplify. So a over b, the quantity to the nth power, is a to the n over b to the n. A and b are both not equal to 0. They can't be zeros. They have to be non-zero numbers. And n is an integer in this case. So in the case of 3/5 to the 3rd power, it's 3 cubed over 5 cubed, or 27 over 125. X over y to the 5th is x to the 5th over y to the 5th. Here's why that should make sense. X over y to the 5th power means that product multiplied 5 times. So the x's Getting lazy about writing it over and over again. Now you see why we have these tricks, these rules. Because otherwise, if we had to write it out every single time and then see that this is 5 x's in a product and on the bottom 5 y's in a product, gosh, would that get tedious after a while. Let's try some. All right, so first you're squaring what you see, then simplifying if necessary. Now, none of these can be simplified. Just wanted you to make sure you understand what's going on. We will have some more complicated exponent problems in the last 2 slides. So squaring this means multiplying m to the 4th times itself. Well, we learned in the last video that you can multiply those exponents, but think about why that's working. M to the 4th times m to the 4th is m times 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 m, and if you've been paying attention, that was 8 m's. Okay, and then the denominator is also going to get squared. 5 squared, 25. So in these problems, because there are variables involved, I am going to go ahead and simplify the numerical part of the answers. So I'm not going to leave 5 squared. I'm going to go ahead and write 25. All right, so this is 4 cubed. I will write 4 cubed for the moment because I'll bet a lot of you don't know what that is off the top of your head. And then again, same thing here. We're multiplying those exponents. Think about why. Because it's r cubed times r cubed times r cubed. 1, 2, 3 times 3. 3 times 3, 9. 4 cubed. 4 times 4 is 16. 16 times 4 is 64. So 64 over r to the 9th. You'll like this. This is kind of cool. I bet some of you can already figure out what to do. N to the 6th over m to the 4th to the raised to the negative 1. That whole quantity raised to the negative 1. Flip-flop them. Flip-flop them. Exponents don't change. And you can think about this from that perspective of doing power of a power. If I do that and I multiply my exponents, I'm going to have n to the negative 6 over m to the negative 4, in which case we would do like the example we did last video and switch them. All right, let's try this one. Now be careful. We are multiplying those exponents. That will be t to the 18th power. But it will not be 2t to the 18th power. It will be 2 to the 3rd power. Because 2t to the 6th cubed means this thing times itself 3 times. So 2 times 2 times 2 would not give me 2. It would give me 8. P to the 4th raised to the 3rd would give me p to the 12. Don't try to simplify anything just because you see an 18 and a 12. Don't think that you can do anything with those exponents. 2 different bases, guys. 2 different bases. Okay, let's do this last one on this slide. So the first thing I'm going to do when I have a quotient with a negative exponent that's not a negative 1 is I'm going to go ahead and flip-flop the insides. And I'm going to make that exponent now positive. That is equivalent to jumping the line to switch the sign. That is equivalent to jumping the line to switch the sign. So now I'm just squaring everything. 5f times 5f would be 25f squared. H times h would be h squared. And that expression is through. So quotient powers, just about as easy as the product powers. I want you to go ahead and now look at this last page. If you're feeling brave, you can try and solve these on your own. Then take a look at my work. If you're not feeling brave, that's okay. Just bear with me. We'll go all the way through them. I'll probably do 71 and 72 on this page, and then I'll probably do the next 2 on the next page. All right, let's look at this first one here. Let's color code them. Let's make this one this nice teal color. So we'll do this one in this color. Well, I noticed the negative 2 on that exponent right off the bat. I'm thinking I'm going to go ahead and do the flippy flop and change that to a positive 2. So I'm switching the numerator and denominator because that's what a negative exponent does essentially. If you go back and you look at my definition of a negative exponent, you know, an exponent tells you to multiply by the same number over and over. A negative exponent kind of tells you to divide. And if you think about it, if it's in the denominator like that, it is kind of like dividing. Excuse me. So now I'm squaring everything. So I'm multiplying my exponents. Same is true here because that's a 1 right now, and 1 times 2 is 2. So I'm going to have x to the 8th y squared on the top. And then on the bottom, I'm going to square the 3 and have 9. I'm going to have x squared and y to the 10th. Now, unfortunately, this problem is not finished. I just did my power of a quotient part, but now I've got to simplify everything else that I see. So the 9 won't be simplified. That will definitely be in my answer. But I can Actually, I didn't mean to do that. Let's go ahead and scratch that part. But what I can do is say, all right, well, that's basically a 1/9. So that'd be 1/9. This is x to the 8 minus 2. Quotient of powers, subtract our exponents. And then y to the 2 minus 10, which is -8. So right now I have 1/9 x to the 6th times y 6th times y to the -8. I'm going to put it back together in the fraction. The y to the 6th goes on the top, x to the 6th on the top, the y to the 8th on the bottom. So we're going to have 1x to the 6th power all over 9y to the 8th power. All right, 72. Let's see, let's find a good color for this one. Pretty consistent and boring. I'm going to go ahead and use purple. All right, so for this one, we're going to go, we don't have any coefficients to deal with. We are finding a quotient of these powers. So let's start off by taking each base and subtracting the exponents. So m to the 4 minus -2. 4 minus -2. N to the 3 minus 7. And p to the -3 minus -8. Be careful with your signs. Be careful with your signs. So let's switch colors. I'll use this bright yellow to go ahead and make some changes here. This is going to be addition. So is this. So that means the exponent on the m is a 6. So m to the 6th. N to the -4. We'll deal with that in a minute. And p to the +5. If you think about this as a fraction, the part with the -4 exponent needs to move. So we keep the m to the 6th, p to the 5th up in the numerator, and n to the 4th moves to the denominator. So to switch the sign on the exponent, you got to jump the line. Switch the sign, jump the line. 2 more, and this video's over. The one that's marked 75 is next. So again, we have an exponent to deal with on the outside, and we're going to go ahead and apply that exponent to everything. So it gets applied to every one individually. Power of a power, multiply your exponents. So we end up with a to the -1 times 6, or -6. B to the 3 times 6, or 18. And C to the 1 times 6, which is 6. And then on the bottom, a to the 2 times 6 is a to the 12th. B to the 4 times 6 is b to the 24th. Now I need to use my quotient rules. Powers with the same base, subtract the exponents. Power with the same base, subtract the exponents. Nothing to do to c to the 6th that's guaranteed to be in my answer. -6 minus 12 is a -18 on the a, times b to the 18 minus 24 is -6, times c to the 6th. So that means that my parts with negative exponents have to drop. So c to the 6th in the numerator, a to the +18, b to the +6 in the denominator. Last problem from the video. Let's take a look at number 76. Green. Christmassy colors. Weird. Oh, look. I was all inconsistent and stuff. There we go. All right, so this one we're going to rewrite a little bit because we've got some negative exponents. So first, let's do the power of a power. Power of a power, multiply your exponents. So I have -4 to the +4 power over -3 to the -6 power. Now I'm going to rewrite this by taking the one with the negative exponent and moving it upstairs. So what we're going to end up doing to find the answer for this is -4 to the 4th times -3 to the 6th. And that's going to give me, let's see, -4 to the 4th is 256. 3 to the 6th power is 729. And they're both positive because you have an even power of a negative number. That means that if I multiply this out, there's enough pairs of negatives that the answer comes out positive. Negative times negative positive, that's 2. Negative times negative positive, there's 4. 6, so there's an even number, definitely coming out positive. So 256 times 729, so times is 186,000. Would help if I had the pen tool. 186,624. Phew! Not too stressful. You'll be working a lot with exponents in class coming up. See you guys in class.